Is it okay?
Yes, sir.
Yes,
Okay,
sir.
sure.
Yes, sir.
So I can start. Sure. Thank you. So today our first session start from the ASIC. So what is ASIC? As I told, ASIC is particularly you can say it is a completely hardware, and it is completely task or goal specific. It's a goal specific. No more. Now in single purpose processor, here also we are making a processor that is purpose also single, like maybe ASIC. So to show that programmability is associated with it itself. Okay. And that means already I have mentioned ISA is the define the power of the microprocessors, that is a GPP. I told that one example of the TMS, that means one application specific processor, and ARM, it has a two mode, one is thumb and is the normal mode. Okay. ARM, another I have given 8051 is a peculiar microcontroller. Okay, so microcontroller, microprocessor, and ASIP, application specific processor, because these are used for DSP, digital signal processing. So you can compare the ISO of this thing. This is the assignment number 1. Did you get it? The assignment already I mentioned through Abhishek. Next is that
Yes, sir.
if you see the microprocessor architecture, that is the microprocessor architecture, just notice it. You will find that the microprocessor, already I mentioned that a control unit is there, ALU part is there. So this is the actually basic processing unit, and to perform the processing unit we need a cache speed, some on-chip memory, and some is a control register. This is also called we control register. Okay, and this is the cache speed register. From data can be retrieved from here, and we can store the data also there. So it is a programmable. So this is completely programmable. Okay, some ports also there are through which I can program the register port generally, and that is our programmable port. Some memory, some interrupt for external interrupt signal will come through here, and this is the clock. So this is the fundamental of the microprocessor. If you notice it, there is no analog digital converter except the clock. There is no concept of the timer, that is not there. Some communication port to communicate direct with the processor unit, so such type of things are not there. Whatever I have to communicate with the port and or the only interrupt. Are you getting my point? So this is the typical examples of the microprocessor. From today's class, you just remember microprocessor, mostly you have to think about the data path, that is our data path concept, and one is control path, that is our control path. So that is the basic concept of the microprocessors. Okay. After that, in the microprocessor, I have given the most important features, that the speed is the requirement. Already everything I have discussed, just recall. Speed, power, size, and cost. The specification of the selection for the our embedded system. If you choose a particular microprocessor in embedded application, that time you have to think all these things. Now is every clock cycle fetch, decode, fetch of operate, execution, and then write back. So these are the different phases operations going on in the per clock cycle. So instruction per cycle per second, clock speed, these are the very important. And these I have already mentioned that the architecture, or we can say benchmark for processor design or processor architecture, we can compare. That also last class I have designed. Now in case of AC, that is the microcontroller that's mostly used for embedded application. That means reading sensor data or actuation, events, disk type, digital camera, microwave, everywhere these are applicable. Except the micro, these are this part is a timer, analog digital communication port. This plus the processor unit. I told that this plus processor unit. Additionally, you will get the console micro on chip memory is there. It can be program memory, it can be data memory, but this generally in case of on chip memory of the microprocessor, this is a single memory, mostly single memory, but can be separate also if it is a hybrid architecture. And specialized instruction for bit elevation, though port you can generally we can do. So this is the SIP already we have discussed. Now is a special timer we are now explaining, that is called watchdog timer. What happened that suppose the timer automatically check that this computer sends a particular signal. Maybe some signals, clock signals are there, it is also counting. Maybe it count from 15, 15, 10, 14, 12, 13, 12, 11, 10 up to 0. It is maybe this way it is counting. Okay, or this way it may be counting. Suppose it happened that there is a system in your computer that a event is take place within 50 seconds. An event is takes place within 50 seconds, and after 50 seconds a signal is coming, and reset the timer again 15. After 50 seconds maybe some event is coming, reactive sequence event is coming, and this is takes place. If within the if the proper execution takes place, so after 15 seconds, each of the 50 seconds it will deliver a pulse, and that will reset the system. Otherwise it will reset the entire system. It is reset the counter. So watchdog timer, if it is a watchdog timer, it will notice the occurrence of continuous event. If 15 second passed and the signal is not coming out, a particular signal may be output or something, so it will thought that the system is hang, so it will again reset the system, it will do. And that is very important in case of our embedded system. That's why I mentioned a watchdog timer is a hardware timer that automatically generates a system reset if the main program neglects to periodically service it. It is often used to automatically reset an embedded device that hangs because of software hardware fault. Is it clear to you, or I have to discuss it a bit more?
Sir, that watchdog timer is default 15 seconds or it can vary according to the microprocessor?
Yes, particularly watchdog timer you have to choose based on your requirement. If suppose your microprocessor need or continuous tasks, perform some tasks within the 15 second, so watchdog timer you can set as a 15 second. You can program it the watchdog timer's value.
Okay, sir.
So if you suppose that one event is there, suppose, okay, let's see, in a boiler, we are doing some boiler application. This is a one boiler. Okay, suppose this boiler, and boiler need when the pulse is coming, the temperature current is coming, it needs 15 seconds to heat the water, suppose, and the heat water go outside. There is a clock signal is there, and that is timer, watchdog timer is there. Whenever you switch on it, switch on, timer also know, see, like in this clock feature, both are in the per clock sequence. What happened that after 15 seconds, when the water is heated and it will pass to the another part, then after 15 seconds it will come here. It will come here and reset the counter. Again counter will be 15, 14, 13, 16, and this will be heated. Once this water is passed, again the cool water come, again the cool water will be started heated. Now after every 15 seconds the signal will come. So if after 50 seconds the signal will come, here is a connected. After 50 seconds the signal is coming. So again after 50 seconds it will come. Signal will be 15. It will be fitted again 15. So again it will come. Again it will be 15. Again it will come. So what happened that if event is fired, it will reset the counter. When it will reach 0 and still this signal has not come here, it will understand that there is some fault happen in the software hardware. That's why what it will do, it will go and reset the system. Otherwise some explosion can happen. Otherwise some catastrophe can happen. So in the embedded system already I told, particularly if it is work in hard real time, it's a very time constant. So watchdog timer will that means you just keep yourself a guard, you have keep a guard, or you can watchman you have given to watch the event. If the event takes place after 15 seconds, you will get a signal. Okay, 15 seconds happen. So guard will again reset his mind. Again it count 15, 14, 13. When it reach 1, a beep sound will come. It is coming. Okay, again it will go 15, 13. So in this way, it will reset the clock in the clock. Always reset itself according to as per the time of the event. When as soon as it is found that the event is finished. Still beep sound is not come. Then watchdog timer not only reset itself, it will reset automatically the entire system, and that is very important in case of embedded system. Clear? So watchdog timer, it is not present in the microprocessor. It's a special feature of microcontroller. Is a embedded chip is very because embedded chip mostly once developed, if it is given in a system where without human intervention it will be work, so that time this very essential to realize it. Now digital signal processor, the best example of a application specific. The digital signal processor cannot be used for other processor application. Okay, so what the distinguish have the others from? It has several execution unit. In case of micro comparing microprocessor, it will have some several execution units, multiply and accumulate. That means if you notice mostly the discrete Fourier from or first Fourier transformation or discrete Fourier transformation, you will find that in the both the cases, discrete Fourier transform or first Fourier transform, they are doing some mostly calculation like in this way: x1 y1 plus x2 y2 plus x3 y3, like in this way equation will happen. Getting my? So one first is multiply, and then first initial is 0 with that, then this value will be added, this one again multiply, this will be added, again multiply, this will be added. That means you have to multiply and store the result in a location, again multiply, add it and store the result in the other. That's why it is multiply and accumulate instruction within a single cycle it have to perform. That's why it needs one multiplier and one adder, and after multiplication when addition is going on it will store again within its location. So that is that an efficient vector operation is required. So using DSP you can't do other applications. That is the one way to, that's the best example, like the Texas Instruments that developed this one we call is a TMS. Okay, so that's you can also follow.
Sir, could you explain the multiplication part once again, sir?
Micro
Sir, the multiplication part, sir.
microprocessor, this one.
No, sir,
Sir, the
he's saying, can you
multiplication
explain the
part, sir, the
multiplication part?
multiplication.
Multiply and accumulate. Not getting it. Can you repeat it? Which one?
Yes,
Sir,
sir.
last যেটা পড়ালেন multiplication ওইটাই।
Yes, sir, the multiplying.
This one.
Yes, sir, yes, sir.
Okay. Here I am telling that the function is like
Yes, sir.
most of the Fourier
Yes, sir.
transform you will find such type of function. Are you getting my point? Here that you have to multiply and add with the previous one. Multiply and add with the previous one. You get this type of equation. That means if I express this equation, it looks like in this way: x1 y1 plus x2 y2 plus x3 y3, like in this way finally xn yn. Are you getting my point? So function is like in this way. Okay, so what
Okay,
is
sir.
target that you have to first multiply and then you have to add it. Initially you have to 0. Suppose it is like in this way: f equal to f plus summation of xi yi. I want to like in this way, which looks like in this way actually. So I can't do this like in this way. That's why here is the formula. Initially sum equal to sum plus, if you continue this process, that means you can write xi yi within the loop. You write for I equal to 1 to n. Actually formula here look this way, but what hardware feel that in the hardware first you have to multiply this, first you have to multiply, then you have to add, again multiply and add with the previous one, multiply again add with the previous one. That's why it need multiply and then accumulate the result. Such type of mostly processing takes place in the digital signal processing. Getting my point? Most of the application digital signal processing this happens. So that's why we follow here multiply and accumulate concept. Any question from this? Clear?
So what is the sir, what is the full form of TAMS, sir?
Is a
So
Texas
TMS,
micro.
TMS.
Yeah. It is actually Texas Instrumentation instruction set. I know, but this is the name of the. That means ARM is a processor. It is a digital signal processor. used by the Texas. I think TJ Texas. So some microcontroller system, I don't know the actual phone number, you check it. So Texas instruction set architecture, it is actually use the TMS. Okay. If you follow here, I think if you check it,
And so what
TMS,
is DFT and FFT?
DFT is a discrete Fourier transform and FFT is a fast Fourier transformation. I think it is a mathematical concept mostly used in the
Oh, okay.
DS image processing.
Okay, okay.
Okay, clear. Uh, it is written TMS as a
Yes, sir.
transcranial magnetic stimulation or something is written. Okay. I don't know if this is the full form or not. Full form for
So
SC.
that is a medical term, sir.
Yeah. That is SC. In case of SC with the Texas, I have to write Texas. Instrumentation. Texas instrument is given TMS. Is a digital signal processing. That is, I know digital signal processors. Full form that now mentioned, I think probably. It is written just like a TMS, Texas Instrument TMS. They have written some name like Intel company has written Intel i20, i10, like in this way. It is their code. Okay. It is their code, particularly one best example of the digital signal processors from Texas Instrument Company. It is launched on April 8, 1983. Okay. Which was then fastest DSP on the market. और उसका जो प्रोसेसर है उसका ना कोड था TMS 320010। मतलब माइक्रो कंट्रोलर में तो प्रोसेसर होगा ही, होगा क्या नहीं होगा एसिप में?
So
So another is that microprocessor in a chip, that is the concept of the IP core. That means we are not actually fabricating all these things. I am giving the architecture, maybe in Verilog code or VHDL code, that means hardware programming level code I am giving. That can be as a proprietary. That means your microprocessor you have developed in a program and you are just selling your program as a software. That is called intellectual properties. Very important thing, IP core. Mostly you will find in the industry of the microcontroller, because application used and based of the application different microcontroller are used. So what happened there, instead of fabricating the entire microcontroller, they are based on the application, they are designing the that processing unit, or you can say the microcontroller bit. They call is a IP core. Okay, intellectual properties. So what happened that intellectual property, that design a pre-designed codes are there which is synthesizable VHDL code. Okay, present code, synthesizable VHDL code. After taking that code, you can program accordingly, and finally you add couple of hardware instruction set, and you can finally make your chip also. So some part of the program is given in hardware level, and after that hardware getting that code, or you can say core, you can program it and you make it your customizable chip. So that is also the best reason in case of ARM. You will find Advanced Risk Machine Company ARM. They are very famous in the microcontroller domain. Microcontroller domain, they are leader. Can you tell me in the microprocessor domain, mostly widely used microprocessor? Any company?
Sorry, Intel AMD.
Intel.
Intel.
Intel, sir.
Mostly world probably the Intel is the market leader. Are you getting my point or not? In case of domain of the microprocessor, Intel has a microcontroller also, but like microcontroller in microprocessor domain, ARM is the leader. If you start working on embedded system or some embedded application in the domain of ASIP, you will find ARM is the boss in these cases, not Intel. In the market of computer microprocessor, Intel is the dominant person. You can say the market leader. Here ARM is the market leader. Why Intel can't beat it? The problem is that Intel fabricates their own chip, i10, i7 or i9, whatever you're telling, i3, i5, all are Intel fabricate their chip and you have to purchase from the Intel. What ARM doing? ARM making IP core. Instead of fabricating the IP core, they are making and they are selling the IP core. Anyone can purchase, maybe Samsung, maybe purchased by the iPhone, that means Mac. Any company, they can take this their IP core and they customize accordingly and they fabricate it. So design here and fabricate by anyone by themselves. So huge power applications are there in case of these cases. So that's why ARM, the business strategy of the Intel and microprocessor, the none can copy the Intel chip. So you have to purchase. I know initially it was still ARM is competing with him. Sorry, not ARM, AMD is competing with him, but they are leader in GPU architecture. I think leader is the company's name is. Can you tell
NVIDIA.
me?
Yeah.
Yeah.
NVIDIA.
NVIDIA. Yeah. So like in this, each of them have some special application and they are doing. Yeah. Another company, except NVIDIA, a
Sir, in
company is then
GPU.
GPU with
AMD,
name.
sir.
No, a name with A is there. I can recall the name with name A. It's starting with the name A. I can't remember at this moment. That also competing, but NVIDIA is the leader in this.
They brilliant
AMD.
chips, I mean graphic chips, sir.
I am telling the GPU. Whenever GPU is made by the NVIDIA GPU, है ना? Co-processor, not processor, co-processor. Processor should be always there. Along with the processor, there is a co-processor concept. We taught you in the architecture classes like floating point processor. In this way, NVIDIA is a graphical unit processor, GPU.
Sir, AMD when you are talking about ATI.
Maybe like in this, A base ATI or something. Another, I think, GPU architecture. They also competing with the NVIDIA. Okay.
Sir, yeah, sir, ATI was yeah, like purchased by AMD, so they go under the same name now.
Now maybe.
Uh,
That's why I forgot. In earlier days, there was a company was like in this way. I forgot the actual. No problem. But see, microcontroller domain, you will but not there. That's a IPA concept because they are just selling their IP core instead of the entire chip. The IP core you can take from the ARM, and then it's very easy. Those easy. That means cheap also. But he thousands of IP code they are sending. So microprocessor in a single chip like intellectual property, the software also possible. It is not always the hardware. So whenever a question is come, did you see a microprocessor in a software part? So you can say it is possible if it is IP core. Okay, you can take and purchase. So today our target is that we will go for the single purpose processors. It is a processing unit. Purpose is single. So I can say it is like a SIP architecture, like application specific, but here I may say one application that is single. That's why I mentioned single purpose processor. Okay, so SPP like GPP general multi-purpose. Now we are dealing with the single purpose. What is the single purpose? Digital circuit designed to execute one program. If you have some processor that will design on program, very important thing, because nowadays after these classes we'll start designing a processors, how to design a processor. That means if you design, then fabricating unit will follow your design. So that is the main thing. Mostly co-processor, accelerator, peripherals are single purpose because your GPU is the best example of the co-processor. It performs only those tasks which is required by it. Only not another than, but only GPU can solve in the you have some processor, main processor unit, and some tasks of image processing or something for machine learning application, vector computation. You take the help of the GPU, but your main processor should be there. So this type of concept, single purpose processor, mostly used in these cases. Okay, that's why I'm telling that you can use here. Now in digital circuit executed exactly one program. That is the main target here. Features is that contains only one component needed execute single program and no program memory because only one instruction. Am I correct? Only one instruction to be executed. Clear? That's why no program memory because it will be hard coded. Benefit, it will be very fast, very low power consumption because less number harder automatically in your mind it should be understood that less power consumption, and it is small size. size will be very small comparing the general purpose processor and other processor design. Okay. Now our main criteria that actually what is control path and data path, CP and DP. Mostly you have to remember.
Sir,
Yes, yes.
sir, could you go to the previous slide, sir? Once I had one doubt, sir.
Sure.
Sir, like single purpose processors like are like ASIP, or ASIP is a type of single purpose processors, sir?
Here our main target is a single purpose processor. Then one purpose I will make. Only one. So we are designing a processor, not GPP. Actually GPP is multi-purpose. We are not making GPP. Simpler GPP you are making, which are only one task it will perform.
No, sir. Oh, acha.
No. You're not clear. You tell me, because sometimes I can't receive your question properly also in the online. But try to
Sir,
get your question.
actually, my question was that is ASIP a type of SPP, or is ASIP and SPP different?
Wait a minute. Audible now?
Yes, sir.
Okay. Actually, single purpose processors, you can say like GPP, where multiple tasks take place. I am not dealing with the SCP. I am telling the single purpose processor looks like SCP because application specific, and that is the one application in these cases. That's why I'm telling it look like SCP, but it also the main I am following actually architecture of GPP. Okay, because if in a GPP you have a multiple tasks, then you should have a program memory which contain multiple tasks. Are you getting my point? Since I am purpose here only one, so no such memory is there, it will be hard coded. Suppose I am doing only plus addition. So only I will take a adder circuit which will perform the addition. No other memory is required. I will directly adder will be hard coded instead of program memory. Am I correct? So since it is a general purpose like
Okay, sir.
architecture, but since it is single purpose, actually I am trying to reach the analyze the ASIP behavior as well as the GPP. Both I am analyzing here. If single purpose, when you will analyze the multiple, automatically this program memory will become. Then it will go to the GPP architecture. If I am not analyzing program memory with single task, it will go to the ASIP. So both I can analyze with this example. Is it clear?
Okay, sir.
Now, what is actually controller? First, it is the abstraction. I am doing for abstraction, abstract model I am following. That there is a controller, there is a data path. In controller, some external control signal will come and that will give the external output. Also, there is a communication between the data path and control path. Always remember, controller controls the flow of the data. So if you enlarge it, you will find that inside the controller there is a state machine which is count the state, and based on the inputs is coming from the based on the input coming from the data path, it will signal the generate the next state. So that process will continue and next state. It is just like a finite state machine which count the sequences of steps which will be executed by the machine. So that's why one controller will be required to execute the task. Since only one operation is there in SIP, so one signal will maybe perform here. So complete control unit will be very simple, 1 and 0, 0 and 1, two step. So two step machine will it will perform. So here may easily can be done. So in data path mainly register, and there is a functional unit mostly ALU, and there is a register that is I'm calling sketchpad register. So abstraction it's look like in this way. Now, if you go more deeper, you will find, suppose I have to solve before that, okay, before coming to the part, suppose just I am opening my whiteboard. Is whiteboard visible? I am opening a whiteboard. Is
No, sir.
visible? No, I think I have to share
No,
it
sir.
again. Okay, don't worry. Now visible? My whiteboard is
Yes,
visible
sir.
to all of you?
Yes,
Okay.
sir.
Suppose I have
Yes,
to
sir.
perform one operation for I equal to 0 to n. This, and inside this you have to do total equal to total plus a of I. This you have to perform. What is the number of tasks here? What is the number of tasks here? One task. Am I correct or wrong?
Sir. Yes, sir.
One task. Only one task it will perform. So if you notice it,
Yes, sir.
I have to get an index value here. Some index I have used here. Okay. And it is stored here. So to store this index value, I need what? One register. Suppose this is a register 1. Not clearly visible. This is a register and total another register. So how many registers required? Only register 1, register 2 is required. Am I correct or wrong? Because what is the value of I 0 to 1? It will take the value and to check. So I have to take like in this way from the register. So what happened that if you go to the our data path, I need these things. One register to store the index value, another register to take the total value, and one functional unit. Here it will be plus. One functional unit is a plus. Clear? That means only ALU, single ALU, and that is there is no ALU is required. Only adder is there sufficient. ALU perform multiple arithmetic and processors. Just 1 minute. So here you will get one addition only. This is for addition. So only a single adder will solve my purpose. So no ALU also required. Very simple task. And a data memory. I am writing DM where the value of all this will be stored. Is it clear? So it will access from the data memory. And during the computation, this register 1 and register 2 will help this part. Clear? This is simple. And there is a controller. In controller there is a control logic. That means first it will take the addition of this, that means take the value of this one, then plus it with the previous one and then store it. So that will be the control logic for this one. That means if it is a R1, some value of R1, or it is a R2, through R1 I will get a value of AI, and from R2 directly I plus it, then it will be stored again in the result to R2. So that is the logic. So what happened that control signal first will enable this part. So automatically by the value of index from the data memory, the data will be loaded here. So that is the one control unit. When it will enable this part, it have to enable this and these two also. From this and this index value, it will take the value of this one. And after that in second clock pass, when it will enable this one, it will enable this and this both. So control logic only two signal, one for this part and one for this part have to enable. Are you getting my concept? Is it clear or not clear? What I am telling is it clear or not clear? Tell me, otherwise when I start designing the single processor, very critical problem will happen.
So can you explain the last part once again?
I am telling that suppose this is the R1 value. R1 is the index value. From the data memory, you have to come the value of A of R1. Whatever was the value of I, you will get the value, and that will be added to the R2 in the next phase. If this value is not available, I can't addition do it, and finally this will be stored in here. Now my question is that your control logic first will enable this part. When this will enable this part, this is not available. So it is a control logic 1, it is a control logic 2. When C2 is enable, then C2 also enable this also, that it should be available, it should be available. Okay, and when C1 enable, only this C1 and this from the data memory C1. So control logic will enable C1 and C2. These two signal will come out from the control logic to enable this operation. Am I clear this one? That's I mentioned that your control logic will be also simple and only two sequence of operation it has to do. Only two single operation. That's a simple control logic, and also there is the, you can say, status register, or you can say the sequence counter, which will count this one. So I think this is my actual SIP.
Sir, could you explain again, sir?
Which one? Tell me. आज इससे ज्यादा नहीं जाना पाएंगे क्या मुझे
Sir,
आगे?
the SIP part, sir, like after the registers.
Okay, I am telling that I have to implement a function, whatever the program I have given. Suppose this is the program, it is given to me, I have to implement. Okay, if you notice the program, only how many variables are there? How many variables are required? In program, during program execution, I am not telling to storing, n is stored in the data memory. So nothing I have to recall. Even array is stored in the data memory. So that is not my that is not required in the during my execution. I will fetch one by one. So but I am telling the how many variable required in program mode. That means execution. In execution, I have to get one value. To get this value, I need to count index, which will change during the program. The program continue and the value will increase. I now 0 initially, then 1, then 2, then 3, then 4. So it will be changed during the program. It's a variable. That's why I am writing the variable value varies. So that for values I need one register which will contain the value index. Is it clear? Is it clear or not clear? First tell me. Then definition of the variable or register I am using.
Sir. Yes, sir.
It is clear to you? Okay. Now you check another value to store it the total. So another register I am taking. So total. During the design, when a program will be given to you, you have to think, because you will design the chip or you guide the fabrication need to make up the chip. So what you have to do, you have to make these two registers. One is index, another is the total. You made it? So only two registers solve my purpose. So I will take very less microcontroller which have only, or microprocessor which have only two number of registers. And even one LU is not required, only adder circuit is sufficient the purpose, because it will do only addition. Purpose is single, only addition. So only adder circuit is sufficient. In ALU, it is a complicated arithmetic subtraction, addition, deletion. So the logic you have to perform. Here only one single adder. So no ALU, only one type of simple addition. So adder is sufficient. And we are taking the value from DM for the array from data memory. The simple data memory which stored the value of n and some array. So huge memory is not required. My condition that to implement it, the program logic, what will be my control logic? What will be my control logic? That is my target. My control logic should be like in this way, that during the computation, actually what you are doing during the computation, in your computation, initially you know that I have to take, with the help of R1, I have to compute the value of AFR, because from the DM I will access that value of the index, I will get the location and it will be stored here. Okay, so that is the one my memory, and finally I will perform the addition with the R2. To sequence this operation, I am telling that initially I have to enable that registers control unit 1 and also this one control signal 1 C1. Throw C1 maybe bit combination 00, these two part enable, and from the data memory this will be available to this storage. It is a temporary storage, it will be available, though I can say through the register directly I am accessing the data memory. In here I am showing it, but actually you are accessing the data memory. You are not taking with any additional memory. Remember, only additional memory is the R1 which contain the register, and through the register you are taking the, okay, it is better I am not writing it here, I will be confused. So you just remember the C1 is the control signal, enable it, and Cn also, through Cn a data value is come from here. So during that only control signal is C1 is here. C1 is the value control signal which enable these two to come here, and also during the C1 this value will be available here. But only this will be enabled when control signal C2 will appear. When control signal C2 will appear, these two values appeared here, and finally addition and it will be stored there in C2. Now it will be activated on C1. Now in C2 this is for writing and C1 this is for reading. So two control unit signal performing the different tasks. That's I would like to mention here, that how calculation takes place. So during this purpose, what I would like to mention that only simple control memory is sufficient, having some status register. I think this sequential will count 0001, only two control signal it will generate to perform this task. Am I clear or not? Any doubts you can raise. अरे भाई हो क्या?
Yes, sir.
और सब भागा?
नहीं सर, अभी भी है.
अच्छा अच्छा अच्छा. No, just I'm telling that this the one concept I told here. Now if you go for this one, now suppose I have to make that single purpose processor I have already mentioned to you. Okay, now what I am telling, a custom single purpose processor. That is a processor we are making which will perform GCD of two number. Is it clear? GCD of two number. First algorithm. If the algorithm not clear, then tell me.
Sir, your microphone
Sir,
glitched again.
Clear?
Your microphone glitched again. It sounds really low.
Sound. Sound is not coming.
So it's
no,
very
sir.
low that
Very low,
barely.
sir.
Now,
Yes,
Yes,
sir.
sir.
It
Now
is
it's
good
okay.
now.
is it okay?
Yes, sir.
Okay, okay. You check the algorithm and tell me. The algorithm I have written is clear to you or not? See, suppose here written I have integer p and q. Oh, sorry. Now available visible single purpose. Okay. Now here you check two variable p and q. Is it clear?
No, sir, it's not visible, sir.
Sir, it is
Sha
visible.
Not visible? Okay.
Visible, sir. It is.
Visible, sir.
I am actually using the tool name is Sharnal. Sharnal is visible to you?
Yes, sir, visible.
Yes, yes, sir.
Okay, sure. So here PQ I have mentioned, actually these are the internal register or port. So PQ may be here. Clear? So for your understanding, I am telling that where is actually PQ. Now while one. While one means what? Can you tell me? While one?
Infinite loop.
Infinite loop. So until unless I will not stop, it will
Sir,
continue.
infinite loop.
Okay. Now while not go. Suppose if go is symbols is 0, then it will enter or not? It will not enter.
Sir, it is enter if it is 0, sir, not 0, 1.
No, you check there is a semicolon is there.
Sorry.
Notice clearly. So only once the signals is there on the else part, it will go. It is a style using only while I am doing if else purpose. So this when go signal will be available, then these two value will take the value of x1 for externally. Then while p not equal to q, okay, p not equal to q, and inside it you will find that p less than q, then q equal to q minus p, otherwise p equal to p minus q. This will continue until these are not equal. It will continue the process. Actually, by using this, you will find the GCD concept. Greatest common divisor of 2 digit. Finally, you find, and finally P will contain the value of the GCD. Okay. So actually, this is the things algorithm given by the client. Now, what you have to do, you have to first analyze how actually the sequence operation takes place. So if you check it, the purpose you will find that first step while one is true, then it will go this side, otherwise it will come here. It is equal true if the signal is on, otherwise it will terminate if it is one not. Now here after going there is a not go situation, that means it will go here for 0 and come here. This will not enter in the my system. Power is on, but it is not enter in the system until you switch on the power. Already it happened in the car also. You will found that remote clock is open on. When you switch on the that means battery is on, that means battery power is already given. So battery power is a while one. So every time your system is okay. Okay, that is one. Now when you press the remote, then automatically embedded system work like in this way. If you don't press the remote, it will working like in this way. When you press remote, it will start processing according to the logic. So that's why these are the special thing. This is for enable embedded for infinite time. That means it's a powered on. You can say it is a powered on. Enter the loop, and this is the operation on and off, like you are doing according to requirement. The system is ready as per your goal. It will work or it will not work. Clear? Now you see there, if p you initially take the value of p equal to x, then take the value of q equal to y. These two are given the entered. Then in step 5, while not equal to p not equal to q, if this is for, if both are equal, then you find if both are equal, then it will come here because this is a not symbol, so it will come here. Then anyone, because number is 5 and 5, then you can say greatest common is itself 5, or number 2 2, it 2 is the result, so it will come out accordingly. Is it clear? If one number is suppose 5, another number is 15, so this will enter in this domain because p not equal to q. Am I clear this point? Am I clear?
Yes,
Step
sir.
by step. Up to
Yes.
this is clear? Okay. Now here at this step you will find that again there is a, you found this loop, p greater less than q or not. If this condition is true, that means p less than q, is it true? Not true, then it will do this purpose. Otherwise you will go do this purpose. The two conditions I mentioned here, these two, and these are the two loops. If p less than q, p equal to q minus p, and it will come here. Again, if it is not less than, it will go. So in these cases, the enter module takes place. Finally, it will reach again after this loop. After doing this loop, again it will check this condition, again check this condition. Finally, it will comes like in this way. I will get the output. When you reach the output here, this is provided. Then again the system will go to its part. Suppose this entire system required 15 seconds to perform. So within the 15 seconds, if it is not come here, watchdog tiger will brute forcefully set up to come here. That is the purpose of the timer. Now, if you think it in algorithmically what I have to do. So these signals are mostly coming from, okay, before that, again, I have to go a little bit the condition actually. That one I can say. So this is our FSDM. We know it. This is our This FHDM is clear. Finite state machine with data. Finite state machine with data. Finite state machine with data. Is it clear? FSMD. So you can check it. Now for time being, again I am switching to our whiteboard. अभिषेक आया क्या?
হ্যাঁ স্যার আছি
কি ক্লাসে লেট জয়েন করো? তুমি হচ্ছে সিআর একটু প্রিন্সিপাল থাকতে হয় তো।
সরি স্যার আজকে একটু লেট হয়ে গেছে
খেলতে খেলতে তো যাও না, বাড়িতে তো বসে থাকো, তাহলে আবার লেট হয় কেন? Okay, suppose there is a flow chart. Start. I am checking some condition x like previous one, p greater than y, x greater than y. Then you go to some condition, you are checking some condition, and if this condition is true, you perform, otherwise you continue to the from start level. Otherwise, if x less than x, suppose and x not equal to y, also I am checking here, then both the conditions are coming to a path and finally lead the value of z as per the logic what I mentioned. My question is that this is the final result will be stored. This is our final result will be stored, the z. So what happened initially, p and q, suppose I have to multiply. In some example, p and q, I have to do some multiplication. It will multiply. Then I have to add some value with this one. So I am adding with the adding that way I add a p plus star q plus r, like in this way I am doing. So I am doing some r, and finally entire equation is divided by with s, like in this way. So I am dividing finally with the s, and this is my goal. So what you will find that astonishingly initially I have to what, enable this one first. I have to enable this one. My control signal will enable this unit first. Okay. Then p and q will be performed. Now when it will enable this one, that time this and this will be enabled, and this will be that time active. Then you need another control signal. That red signal what I am mentioning, it is coming from the control unit, remember. And then again you have to perform this one. So you have to perform the division, and that time it will be enabled, and finally it will take these are the signals are coming. So what happened if this is my control part, this is my control path, so this is my data path. And in software designing you have to simultaneously do all these things. So what I have actually found, finally I have found that controlled data flow graph, very important in case of our embedded system. It is called CDFG, not DFG, CDFG. That's I am going to represent now one CDFG. Clear? Understood CDFG? CDFG understood
Yes,
or
sir.
not?
Yes, sir.
Okay. Now you will find that what I have designed is like a CDFG. Initially, a value will be there in the form X. See, this is our marks. You can say this is our marks. And here is some value that is come. Sorry, I am using red here. No, sorry. Very important part. If you understand it, you can solve our assignment today. Otherwise, the assignment I will give today, you can't solve it. Try to understand. Very important to all of you. See, after that, I will give this assignment to solve. So this is your assignment. Design a custom signal purpose processor. Getting my point or not? So you have to design these processors. So design this processor, you have to make CDFG. So that's why try to understand this design first, otherwise you will not understand how to solve it. Okay. Now initially I am telling the control signal. Control signal, I am giving some red signal. See, this is at the control signal. It is go below, then it is coming here. These are our control signal. So all these red signals I am considering control signal go to, it is the input from the control unit. This is the output from the control unit. So there is the control units are part there. Now initial value X will be loaded here, Y will be loaded here, and during the suppose X select and Y selects, I am considering value is a 1. When X selects and Y selector 1, that time only this value will be available here. If both these values are 0, only the generated or modified value will be appeared here. Are you getting my point or not? That's why we are using here is a marks multiplexer. It will select from the intermediate value or the your initial value. Any one value will be selected. Is it clear? Is it clear or not clear? I think you don't have any doubt, or if you have any doubt, you just tell me. Otherwise, I can proceed. Is this part is clear?
Yes, sir.
Okay.
Clear, sir.
Okay, so here you will find P and Qs are available. After that, you find that P select and Q select buttons are giving from the marks. This value will come in P and Q. So that is available now PQ. So initial value of the GCD PQ is there. After that, what I have to compare. Now first I have to compare this one where P's value will come, and you will find that Q's will also coming. Now I compare P less than Q, and this compare for P less not equal to Q. I think this is the first condition, and inside this is the second condition. So I will find P not equal to Q, this one. When this will be okay, it will go to the counter signal, it will generate to activate this part. When this part will be activated, then this will go to the control unit and it will require parameter either this minus or this minus. If it is true, then I think this part will be generated from P to minus key and P will be updated. P equal to P minus Q, otherwise Q equal to P minus Q. Anything will be updated. So as per the updation, the value will be updated. Are you getting my point or not? If you notice it in my previous slide, I have told that इतना घटा करके लिख देता हूं, मुझे ही खुद भूल जाता हूं क्या लिखा. बाप रे बाप. So see, if P less than Q is true, then this will be happen. If P less than Q, if P less than Q, so what will happen? Your next step, this will happen. Then this updation will take place. This updation will take place. Q equal to when if it is if P less than Q, so this takes place, otherwise this one. So if it is true, if this condition true, then this condition it will signal one, maybe something. So this control help you to generate, you activate this one, and after that it will output will be activated this one. After finally from these two, the final output Z will be stored here, and that will comes out at my final output. So you notice it that continuous the control signals are coming from here, that is P select, Q select, and that is the condition it will input to the control unit, and from control unit the corresponding signal will enable disable this one. All the signals I have not shown here. So finally it came to that the this is the algorithm, and also if I break it more way, you will find that signal is low like in this way. I have divided X less than Y, X greater than not equal to Y, this, and finally these steps will happen. So that's also I have made. So that's why I have made that this is the data flow, control data flow, all the control logic, and also the data also updation takes places. Okay. That's why I condition these are the parameter which actually control the control unit. That's why I've given these signals are going to the control unit. If you check it, they are going to the control unit. So this is the control part, and these are the data unit part which is coming inside. The control signal coming inside, and they are storing all this like in this way. Okay, understood or not? So you have to practice. Now whatever the diagram I have considered, it is from Frank Bahid book. This all from Frank Bahid book. It is available in the Bahid books, so you can practice it. And that's I given you here like in this way. Initially what I have done here, if you notice the data path, you will check it like in this way. See x not equal to y, this the signal. So these signals will perform this part enable. So automatically which part will be enable, and finally how to start. So today I will upload this slide to our Moodle and you try to get it the notification. So in next class I may ask anytime to submit. These are the all part for these problems I have given. You have to perform these tasks. Not required this all this I will teach you. This is the assignment 2. Do all the assignment properly because mid semester and semester assignment question will be given sometime. And that time it does not mean that you have to copy each other because the problem will be different. So practice yourself, otherwise in the embedded system that will be very difficult to you. Is it clear? So can I stop here?
Sir, how to import U?
Here import U, that means I am telling them some port. Actually you take a variable inside the port like P, you will be directly considered as a P, and integer V is the input already there inside the circuit. So you can consider it is a port to the microprocessor, whatever the port is there for programmable, it is given. Input port U means you just taking the input from other side, and internally V is there. It is coming from external input, that's why I given separately.
Sure.
You just write algorithm considering U and V. Okay. So this is the assignment 2. You have to perform. So can I stop here up to this?
Okay, sir.
Or Chishman, any question?
No, sir.
Orko,
No, sir.
understood?
Yes, sir.
Okay, let's see. That's up to you if you understood it. Dodda Chandu. Dodda Chandu.
Yes, sir.
Where are you? Can you switch on your video? Okay, you are at home.
Yes, sir.
Okay, very good. Did you understand whatever we discussed?
Yes, sir.
Okay. Utsav Samanto. Utsav. Utsav. Utsav, are you there? Utsav, are you there or not? Porikha to exam can be passed by copying each other. Can you get a job by copying each other? कोई तो बताओ इसका आंसर. ये सिंपल क्वेश्चन पूछा गया है. कोरोना देवी की कृपा से तो बहुत सब कुछ पास कर चुके हो. जॉब मिल जाएंगे कोरोना देवी की कृपा से. विकास कुमार है क्या?
यस सर.
हाँ बोलो विकास जी. मैं जो बात पूछा उसका आंसर है क्या?
सर क्वेश्चन.
मैंने क्वेश्चन पूछा कि कोरोना देवी कृपा से तो पास तो कर ले तो बीटेक, क्या जॉब भी मिल जाएगा क्या?
नो सर।
तो आप लोगों को तो हाल तो देख के ऐसा लग रहा है कि जैसा चल रहा है क्लास में, किसी का नाम बुलाओ तो आधा ही प्रेजेंट नहीं रहता। तो ठीक है, कोरोना देवी अगर पास भी कर लेते, अगर जॉब भी दे देंगे तो बहुत बढ़िया। जॉब मिलने के बाद जॉब रख पाओगे? तो ये भी एक बहुत क्रिटिकल क्वेश्चन है। ठीक है, ओके, यू मे लीव नाउ ऑल ऑफ यू। उत्सव को प्राजोता, प्राजोता
यस सर, यस सर।
उत्सव को थोड़ा नौता दो मुझसे फोन करने के लिए।
ठीक है सर।
A friend was there now with you. What is the name of the Nirupam ना?
यस सर।
हाँ, निरुपम भी तो इनविटेशन दे दो, दोनों को थोड़ा बात करेंगे, बहुत दिन बात नहीं किया। निरुपम है क्या? बढ़िया बात है, ठीक है, ओके, ऑल ऑफ यू कैन लीव नाउ।
थैंक यू सर।
Thank you, sir.
थैंक यू।
Thank you, sir.